Okay guys, my name is Dr. Wajid Khan. I'm an anesthetist and intensivist. We'll be dealing with this topic of anesthesia. So we'll start with this topic called as the anesthesia machine and the equipments. It's an interesting topic guys, anesthesia machine and equipments, okay. We'll start with the smallest device that is basically used to start our anesthesia. The smallest device is what guys? The smallest device is the IV cannula. It is the IV cannula, intravascular cannula, right? IV cannula. Now there are different sizes of IV cannulas available, varying from size 14 gauze till size 26 gauze. Size 26 gauze, right? Where the largest bore IV cannula is size 14 and the smallest is size 26, right? So these cannulas are given different color codes. 14 gauze is given a color code of orange, 16 is given gray, 18 is green, 20 is pink, 22 is blue, 24 is yellow, and 26 is purple. 26 is purple. We can remember the colors of the cannula by remembering a mnemonic also guys. The mnemonic is O great God, please bless your people. O great God, please bless your people. O is orange color, G is green color, gray color. One more G is green color. Next is pink color, next is blue, your is yellow, and people is purple. Right? O great God, please bless your people. That's the mnemonic for what? That's the mnemonic for remembering the colors of the IV cannulas. Remember guys, that's the mnemonic for colors. But what we need to understand apart from colors is, which is the largest bore IV cannula. First of all guys, you tell me largest bore IV cannula is used in what cases? I'll give you two cases guys. One is the pediatric case, other patient is in shock. He just had a road traffic accident, he had a massive blood loss and he is in shock. So guys, you think and tell what cannula will be used in shock and what we can use in pediatric. I am giving you two options, 14 gauze and 26 gauze. Now you think and decide which one should be used in shock, 14 or 26. In shock, you require large amount of fluid, large amount of blood to be infused to the patient as he had a blood loss. He is in hypovolemic shock, right? So if you want to give a large amount of blood, you can't give that blood, you can't give that fluid with a thin cannula. You have to go for a thick or the largest bore cannula, which is 14 gauze. So 14 gauze is commonly used in shock-like conditions. Whereas 26, the smallest cannula usually goes in the small veins. Small veins are usually seen in the pediatric age group. So remember guys, 24 and 26 gauze cannulas are commonly used in pediatric cases. They are commonly used in what cases guys? Pediatric cases. Whereas the 14 gauze red or orange color cannula, it is used in what? It is used in the management of shock. It is used in the management of shock. Commonly what we use for almost all surgeries, we use the 18 and 20 gauze. 18 and 20 gauze. 18 is green in color, 20 is pink in color, right? So this is the IV cannulas guys. The largest bore is red or orange color. The smallest is 26. What's the color of it? Purple. Used in, remember, 24 and 26 we are using in pediatric cases, whereas this is the largest one used in the management of Shock. This is the best one for shock, but ideally most commonly we use what for shock? Most commonly used in shock is 16 gauge. Why? Because 14 gauge it's rarely available, or if it is available also, we have to find that thick vein to put that cannula. It is the best for the management of shock, but most commonly we choose what? 16 gauge, grey color cannula. Okay. Now guys, this is regarding the anesthesia machine. This was regarding the IV cannulas. Okay. Now we'll start with what? Now we'll start with the anesthesia machine. But before going to the machine, right, what I need to tell you is, guys, you can see over here is the cylinder, right, and here is the patient. There is a cylinder and here is the patient. Can we give the gas directly from the cylinder to the patient? Yes or no? We can take a pipe, connect the cylinder, and directly can we give it to the patient? Through a breathing circuit, can we give the gas directly from the cylinder to the patient? Yes or no? The answer is no. Why the answer is no? Why? Because the pressure inside the cylinder is very high. The pressure of the gas inside the cylinder is very high. We can't inhale such amount of pressures, right? We can't inhale such amount of pressures. The pressure inside the oxygen cylinder is 2200 psi. The pressure inside the nitrous cylinder is 760 psi. The pressure that we can inhale is 45 psi. So can we inhale such amount of pressures? No. If we inhale such amount of pressures, what will happen? Due to the inhalation of that amount of pressure, the lungs will have a barotrauma. There could be a barotrauma to lungs. So what we do, we take the help of a machine that helps us to reduce the pressure of the gas to an acceptable limit. What is that machine called as? That machine is called as Boyle's machine. That machine is called as what, guys? Boyle's machine. Boyle's machine. Boyle's machine. Boyle's machine was introduced by Dr. Edmund Gaskin Boyle. Dr. Edmund Gaskin Boyle in the year 1917. Boyle's machine was introduced by Dr. Edmund Gaskin Boyle in the year 1917. What is the function of this Boyle's machine? The function of the Boyle's machine is to reduce the pressure of the gas to an acceptable limit. To reduce the pressure of gas to an acceptable limit. And remember guys, once you attach the cylinder to the machine, the gas from the cylinder goes to the machine and then goes to the patient. There is no intermission in the gases. So this is a continuous flow machine. This Boyle's machine is a continuous flow machine. Boyle's machine is regarded as a continuous flow machine. The function of Boyle's machine is to reduce the pressure of the gas to an acceptable limit. Now guys, if you look into this Boyle's machine, remember guys, we know the function of Boyle's machine. What the function, guys? The function of Boyle's machine is to reduce the pressure of the gas to an acceptable limit. Now guys, just look over here. What are the parts that you see in this Boyle's machine? The parts that you see in this Boyle's machine, what is this part, guys? This is called as cylinder. This is called as what? Cylinder. What cylinder is it? You can see the color coding and you can tell what cylinder. Color coding is black body and white shoulders. black body and white shoulders. That is what cylinder? Oxygen cylinder. Oxygen cylinder. Remember guys, oxygen is a bodyguard for us. Hence the color coding for oxygen cylinder is black body, white shoulders. Imagine guys, you become a big doctor and you keep a bodyguard with you. What will be the dress of your bodyguard? He will be wearing a black safari with white cufflinks. White cuffling. Okay? The bodyguard wears that. The bodyguard for human is the oxygen. Hence the oxygen is a bodyguard, no? So what will be the color coding for the bodyguard? Black body and white shoulders. So oxygen cylinder is black body and white shoulder. This is what cylinder guys? This is nitrous cylinder. This cylinder is nitrous cylinder. How is the cylinder attached to the machine? The cylinder is attached to the machine with the help of a steel assembly which is called as yoke valve assembly. Which is called as what guys? Yoke valve assembly. Cylinder is attached to the machine with the help of a steel machine. You can see over here, cylinder is attached to the machine with the help of the steel assembly called as yoke valve assembly. Inside the yoke valve assembly, if you look at the inner surface of the yoke valve assembly, you will see a system that prevents the wrong attachment of the cylinder. Inside the yoke valve assembly, there is a system that prevents the wrong attachment of the cylinder. What is that system called as? That system is called as pin index system. That is called as what guys? Pin index system. What is the function of pin index system? The function of pin index system is to prevent the wrong attachment of the cylinder, right? So if you look at the inner surface of the yoke valve assembly, you will find a system that prevents wrong attachment of the cylinder. What is that system called as? That system is called as pin index system. So once again, the parts that we have discussed are, first is the cylinder. How is the cylinder attached to the machine? With the help of a steel assembly called as yoke valve assembly. And on the inner surface of the yoke valve assembly, you find a system that prevents wrong attachment. What is that system called as? That system is called as pin index system. Right? This was basically the old anesthesia machine. I'll take you to the picture of the new machine. Nowadays, the machine looks like this. This is the picture taken by me in my operation theater. Nowadays, we are having this kind of machine. Why am I showing you? Why didn't I show you this machine before? Why? Because in this machine, you will see the cylinders at the back side. Okay? So, we have finished three parts of the machine. The cylinder, yoke valve assembly and pin index. The next part of the machine is this one. What is this one guys? What is this part of the machine? This part of the machine is called as flow meter. This part of the machine is called as what guys? Flow meter. What is the function of flow meter guys? What is the function of flow meter? Flow meter regulates the gas. Flow meter regulates the gas flow. So anyways guys, we are talking about the parts of the machine. This is called as flow meter. Now, just beside the flow meter, you see a container that stores the liquid inhalational agent. What is this container called as? Come on guys, put some pressure on your brain, not on your pages. When you put some pressure on your brain, you will come to know that device that stores the liquid inhalational agent. The student requires that special device. What is that? That is called as vaporizer. This part is called as vaporizer. This part of the machine is called as vaporizer. Now this green part, just look over here guys, right. Now this green part of the anesthesia machine, the green pipe which is coming out of the anesthesia machine is called as what? This is called as breathing circuit. This is called as what? Breathing circuit. Just beside the breathing circuit, you see a small button that delivers the gases at a tremendous rate. What is that small button called as? That small button is called as emergency oxygen flush. Emergency oxygen flush. What is the function of emergency oxygen flush? Imagine during anesthesia, your patient desaturates. There is fall in oxygen saturation. What will you do? You will push this button, and this button will deliver gases at a tremendous rate, or this button will deliver oxygen at a tremendous rate. What rate are we talking about? It delivers oxygen at what rate? 35 to 75 liters per minute. If at all the patient develops sudden hypoxia, you can just push this button and you can deliver oxygen at a tremendous rate of 35 to 75 liters per minute. So that is emergency oxygen flush. Coming to the last part, just beneath the green breathing circuit, if I zoom into the last part of the anesthesia machine, this is the last part, guys. What is this? Here is a chamber that absorbs carbon dioxide, which is called as carbon dioxide absorber or carbon dioxide absorbing chamber. Carbon dioxide absorber or carbon dioxide absorbing chamber. In this carbon dioxide absorbing chamber, what is it? What is the thing that absorbs carbon dioxide? The thing that absorbs carbon dioxide is the soda lime or the bara-lime. Soda lime or the bara-lime. Soda lime or bara-lime. Soda lime or bara-lime are the two materials that absorbs the carbon dioxide. So this was regarding what, guys? This was regarding this parts of the machine. So once again, guys, have a picture memory. First of all, what is this machine? We are talking about this machine is called as Boyle's machine, introduced by Edmund Gaskin Boyle in the year 1917. The function of Boyle's machine is to reduce the pressure of the gas to an acceptable limit. The parts of the machine, I remember here is the cylinder. Cylinder is attached to the machine with the help of steel assembly. What is a steel assembly called as? Yoke valve assembly. Inside the yoke valve assembly, you will see a system that prevents wrong attachment. What is that system? Pin index system. Then we came into what, guys? Flow meter. Then beside flow meter, vaporizer. Then emergency oxygen flush and breathing circuit. And last is what, guys? Carbon dioxide absorbing material, which is called as what? Either soda lime or either bara-lime. Either soda lime or either bara-lime. So these are the parts of anesthesia machine. These are the parts of anesthesia machine. Okay. So that was regarding what? That was regarding the anesthesia machine introduction. Now coming to the first part of the anesthesia machine, which is called as cylinder. We'll start with the first part of the anesthesia machine, which is called as cylinder. In the cylinder, you need to know what is the material, what is the size, and what is the color of the cylinder. The material, guys. First is what? The material. All the cylinders are made up of a common material. The most common material to make this cylinder, the cylinders are made up of a common metal, guys. What is that metal called as? That metal is called as molybdenum. That's called as what, guys? Molybdenum. And this molybdenum, remember, cylinders are most commonly made up of molybdenum, and these cylinders are non-MRI compatible. Non-MRI compatible. Non-MRI compatible meaning what? You can't take this cylinder into an MRI room. Molybdenum cylinder never take into an MRI room. If you take this cylinder into an MRI room, what will happen? What will happen? As the MRI gets started, the cylinder gets sucked into the MRI machine and there will be a blast. Recently, 1 or 2 years back, there was a case where they took this molybdenum. Patient was basically, he was in the ICU and they were suspecting some intracranial bleed. He was on oxygen. So, there was an attendant who took the patient to MRI. The doctor wrote for MRI brain. There was an attendant. He newly joined the hospital. That attendant took the patient to the MRI room. He did not bother to check what cylinder is it. Okay, he took this molybdenum cylinder into an MRI room and MRI was started. What happened? The cylinder got sucked into the MRI machine and within seconds there was a blast. The patient died, the attendant died, right? So you need to understand, guys, molybdenum cylinders are non-MRI compatible, but nowadays we are having cylinders made up of aluminium which are MRI compatible. Aluminium cylinders are MRI compatible. Right? Now, what else we need to remember, guys? I also told you the cylinders are storing the gases. Non-volatile gases are being stored in the cylinders at a good pressure. What is the pressure inside the oxygen cylinder, guys? What is the pressure inside the oxygen cylinder? The pressure inside the oxygen cylinder is 2200 psi, whereas the pressure inside the nitrous cylinder is 760 psi, 760 per square inch. Okay? Next, what else we need to remember? Size of the cylinder. There are different sizes cylinder available, guys, starting from size A till size J, where size A is the smallest cylinder and size J is the largest cylinder. Size A is the smallest, size J is the largest, but most commonly what are we using? Most commonly we use size E cylinder. Most commonly we are using neither J nor the smallest A. We are using a middle one, which is what? Size E cylinder. Okay? So that we need to remember. Next is the color coding. Different cylinders are given different color codings. Why is color coding given to the cylinder? Why? Because by looking at the color, you can easily tell what gas is being stored in the cylinder. Right? So there are different color codings given for different gases, such as oxygen. Oxygen means Salman Khan should come to your mind. The movie of Salman Khan, Bodyguard, should come to your mind. Okay, oxygen is like a bodyguard for us. Salman Khan was wearing what dress in the movie Bodyguard when he was doing the duty? Black suit, white cufflinks. So the oxygen cylinder color coding is what, guys? Black body, white shoulders. Black body and white shoulders. Black body and white shoulders. That was the color coding for oxygen. Nitrous. What's the color coding for nitrous? Okay, while discussing nitrous oxide, I told you nitrous is Neela. Nitrous is stored in Neela color cylinders. Neela is what color? Blue. So nitrous, what's the color? It is stored in blue color cylinder. Blue, complete blue. Whereas there is one more gas called as Antonox. Now sir, what is this Antonox gas? Antonox is basically 50% of oxygen and 50% of nitrous. That is called as Antonox. That's a mixture of nitrous and oxygen. The color coding for Antonox is what? Blue body, white shoulders. Blue body, white shoulders. Now you must be wondering, where is Antonox used? Antonox is a gas which is used for painless labor. Now you must be wondering, sir, for painless labor you thought something different. What I thought for painless labor? Painless labor, I told you, for painless labor we use what? Epidural catheter. Apart from using epidural, we can also use Antonox gas. Whenever the patient is having pain, what we can do when the patient is having contractions, we can put this Antonox gas to the patient and tell the patient to inhale. As nitrous is having analgesic property, it will produce some analgesia. Okay? But again guys, Antonox gas, where it is used is not important. What is the color coding is very important. The color coding is what, guys? Blue body, white shoulder. Color coding for these three gases is very important. Apart from these three gases, there are some more cylinders. Guys, what is the cylinder which is shown in this picture? Which cylinder is it? It is nitrous cylinder. Nitrous cylinder. Some other gases are also, if you can remember, you should remember cyclopropane. There is a gas called as cyclopropane. The color coding for cyclopropane is orange. Cyclopropane is orange. It is stored in orange color cylinder. Helium. It is stored in brown color cylinder. Nitrogen. It is stored in complete black cylinder. Complete black cylinder. Nitrogen is stored in complete black cylinder. right? Cyclopropane is done, helium is done, nitrogen is done. Carbon dioxide, it is stored in grey color cylinder. This you have to remember. 4 gases you have to remember compulsory, guys. Nitrous, oxygen, anthrax and carbon dioxide. Nitrous, oxygen, why? Because these are commonly used for any cases of general anesthesia. Nitrous we always use as a supporting gas with some other gas. Okay, with a volatile anesthetic you always use nitrous. Okay, anthrax also is commonly used for painless labor and all. Why do you remember carbon dioxide, guys? Why we have to remember about carbon dioxide? Why is carbon dioxide used? Carbon dioxide is nowadays commonly used for what surgeries? It is commonly used for laparoscopic surgeries in order to insufflate the abdomen or to create a pneumoperitoneum. First we introduce a trocar, and through the trocar we are introducing a gas called as carbon dioxide to insufflate the abdomen, right? So what is the cylinder of carbon dioxide? Carbon dioxide is stored in what color cylinder? Grey color cylinder. Grey color cylinder. This was the color coding of the cylinder, guys. Okay, this was the color coding of cylinder. Now I told you guys how are the cylinders attached to the machine. But before going to how it is attached, remember cylinder material, size and color coding. Next, how is the cylinder attached to the machine? The cylinder is attached to the machine with the help of a yoke assembly called as yoke valve assembly. Yoke valve assembly. Cylinder usually holds the machine. Yoke valve assembly holds the cylinder to the machine. In the inner surface, on the inner surface of the yoke valve assembly, when you look at the inner surface, you will find these things. We'll just label them 1, 2, 3, 4, 5, 6, 7. What is this? This is called as a pin index system. On the inner surface of the yoke valve assembly, what do you see? The pin index system. What is the function of pin index system? The function of pin index system is to prevent the wrong attachment of the cylinders. Now to have a better understanding of pin index system, everyone look over here. Look at this picture, guys. This picture I'm talking about. Look at this picture. You all must have used this cable and this ports. This is the picture basically of the old generation or desktop computers where you have this cable. Remember, guys, if I give you a mouse cable and I tell you to put in the keyboard port, will it go into the keyboard port? No, sir. If I give you a mouse cable and tell you to put into the monitor port, will it go? No, sir. Why? Because in the mouse cable there were pins given. The pins inside the mouse corresponds to the port of the mouse. It corresponds to the holes of the port of the mouse. Is it clear? So remember, guys, we are discussing about what? Pin index system. We are discussing about pin index system. In the pin index system, the function of pin index system is to, what is the function of pin index system? The function of pin index system is to prevent the wrong attachment of the cylinders, where the pins are present on the machine and holes are present on the cylinder. Pins are present on the machine and holes are present on the cylinder, right? So now, guys, different gases are given different pin index system to prevent the wrong attachment of the cylinder. So just look over here, guys. What is the pin index system for air? Air is having a pin index system of 1, 5. 1, 5. Oxygen, what is the pin index system? The pin index system for oxygen is 2, 5. 2, 5. Whereas the pin index system for nitrous is 3, 5. Carbon dioxide, you can remember it is 1, 6 or 2, 6. But for air it is 1, 5. Oxygen it is 2, 5. Nitrous it is 3, 5. What does it mean, guys? When I say air is having a pin index system of 1, 5, what does it mean? It means if it is an air cylinder, it will occupy the first and the fifth port. If I say it is an oxygen cylinder, it occupies the second and the fifth port. If I say it is nitrous, then it will occupy the third and the fifth port, right? If it is nitrous, it will occupy the third and the fifth port, right? Now guys, remember, there have been questions, two questions on pin index system. First question, what is the importance of pin index system? Pin index system prevents the wrong attachment of the cylinder. Second is what? Second is what, guys? What is the pin index system for different gases? For air, for oxygen, for nitrous, what is the different pin index system? Now guys, remember, pin index system importance, we know that it prevents the wrong attachment of the cylinder. Different gases are given different pin index system, that also we know. Now just look over here guys, what we need to discuss is, how do we remember that air is having a pin index system of 1,5? Guys, if you memorize it, if you buttify it, if you rectify it, you will forget in 7 days or 10 days. You have to store it in a long-term memory. I am here to help you to store this in a long-term memory. So look over here guys, I told you what's the pin index system for air. The pin index system for air is 1,5. 1,5. When I am telling you the pin index system for air is 1,5, just look over here guys, air is 1,5, oxygen it is 2,5, nitrous it is 3,5. How to remember this? The second pin index system for three gases, all three gases, it is same. It is always 5. It is always 5. We just have to remember the first. Second we always remember it is 5 only. First pin we have to remember. Air starts with what alphabet? A. A is the first English alphabet. So the pin index system for air is 1,5. Whenever you are writing oxygen, always write O2. So when you write O2, this 2 comes over here and it becomes 2,5. Whenever you are writing nitrous, what does it mean? Nitrous meaning 2 molecules of nitrogen and 1 molecule of oxygen. How many molecules? 3 molecules. The pin index system for nitrous is 3,5. Air pin index is 1,5. Oxygen 2,5. Nitrous it is 3,5. There is one more gas called as Antonox. There is a gas called as what guys? Antonox. Before going to Antonox, carbon dioxide is having a unique pin index system of 1,6 and 2,6. Antonox is having the most unique pin index system, that it only occupies the 7th port. It only occupies the 7th port. Hence, Antonox pin index system is 7. But sometimes if you are forgetting Antonox, what is a pin index system? It is first of all very easy to remember. It is 7. If you are thinking that you might forget it, just remember how many alphabets are there in Antonox? 1, 2, 3, 4, 5, 6, 7. So the pin index system for Antonox is 7. So remember guys, pin index system prevents the wrong attachment of the cylinder, and different pin indexes system are given for different gases, right? That is the importance of what system? Pin index system. Pin index system. Very, very important guys. What is the main function of pin index system? It prevents the wrong attachment of the cylinder, right? Next after pin index system is what? Pressure reducing valve or pressure regulating valve. Pressure reducing or pressure regulating valve. Now, did I ever taught you about this valve? Why? Because this valve is not seen on the outer surface of the machine. This valve is present on the inner surface. What is the function of this valve? This pressure regulating valve or pressure reducing valve of the machine helps to reduce the pressure. Actually, this is the valve that reduces the pressure to 40 to 45 psi. I told you, machine is used to reduce the pressure. Who inside the machine reduces the pressure? The pressure reducing valve reduces the pressure to an acceptable limit. Next, emergency oxygen flush. Guys, remember where I taught you about emergency oxygen flush? Emergency oxygen flush, where the green color pipe was coming out, no, the breathing circuit. Beside the breathing circuit there was a button. When you push this button, it will deliver oxygen at a tremendous rate, I told you. In cases of hypoxia, that is emergency oxygen flush. It delivers oxygen at a rate of 35 to 75 liters per minute. Next is guys, flow meter. Next is what guys? Flow meter. Flow meter. Now regarding flow meter, this flow meter is made up of a tube, a glass tube, which is called as Thorpe's tube. The flow meter is made up of a glass tube called as Thorpe's tube. This is the flow meter in front of you guys. This is the flow meter picture in front of you, right? Now regarding flow meter, everyone look over here. What are these structures which I am marking on the flow meter? The structures that I am marking on the flow meter are called as flow control knobs. Look at the flow control knobs, you will find some color on the knobs. All these flow control knobs are color coded. You have to remember what? All these flow control knobs are color coded. If you want to on the flow control knob, in which direction you have to rotate? You have to rotate the flow control knob in anti-clockwise direction. As you rotate the flow control knob in anti-clockwise direction, what rises up? There is a small structure inside the flow meter called as bobbin. This bobbin rises up. The bobbin rises up. So remember guys, on the flow meter, you can write from here. On flow meter, we have flow control knobs. On the flow meter, we have flow control knobs which are color coded. So that you can identify. Apart from being color coded, they are also labeled. Okay? If you want to on the flow meter, what we need to do? We need to rotate the knob. We need to rotate the knob in anti-clockwise direction. And what happens? The bobbin rises up. What does bobbin indicate? Bobbin is a small structure guys. Bobbin indicates the flow rate of the gas. Bobbin indicates the flow rate of the gas to be delivered. The flow rate of gas to be delivered. The bobbin indicates the flow rate of the gas to be delivered. What is bobbin made up of? That's also important. This bobbin is made up of aluminium. Remember guys, what was the other thing that was made up of aluminium? The MRI compatible cylinders were made up of aluminium. Right? So this bobbin is made up of what? It is made up of aluminium. This is regarding what? This is regarding the flow meter. Right? Coming to the next structure which is called as vaporizer. Come on guys. What is vaporizer? Vaporizer is a device that stores liquid inhalational agent. Vaporizer is a device that stores a liquid inhalational agent in it. Right? Liquid inhalational agent. This vaporizer is made up of a material which is called as copper material. It stores the liquid inhalational agent. The most common material to be used for making this vaporizer is what guys? Copper. So as you are giving the gases from the cylinder, the gas enters the machine, it goes into the flow meter. From the flow meter, the gas goes to the vaporizer. From the vaporizer, it is given to the patient. Right? So vaporizer produces some vapors mixed with the nitrous and oxygen. So basically you are giving oxygen and nitrous. It goes into the flow meter. From the flow meter, it goes into vaporizer. It takes the halothane vapor or it might take sevoflurane vapor, and then it will be delivered to the patient. So this device is made up of copper material, but this vaporizer, a special vaporizer is required. This is a special vaporizer. Normally all vaporizers look like this. Okay? But a special vaporizer is required for a special gas called as desflurane, which is very costly. Remember guys, desflurane requires a special vaporizer. Why? Because it is having a low boiling point. Low boiling point. This vaporizer that is used for desflurane is also called as Tech 6 or electronic vaporizer. Tech 6 or electronic vaporizer. Electronic vaporizer. That was regarding what? That was regarding the vaporizer. We have discussed the cylinders, the yoke valve assembly, pin index system, emergency oxygen flush, and apart from emergency oxygen flush, the pressure regulating valve we have discussed, the flow meter we have discussed, and the vaporizer we have discussed. Okay? The most common material is important, and why desflurane requires a special vaporizer, that is also important. Why? Because it's having a low boiling point, right?